Okay, so we're live. Hello, everybody. Good morning, good afternoon, good evening from wherever you're joining. We are live. This is DigitalOcean's Tech Talk. My name is Sachin Jha. I work with the product marketing team here at DigitalOcean and focus on Kubernetes and cloud native in general. And with me, I have Bikram, who is going to be the highlight of the talk today. Bikram, can we please have your intro?
Absolutely. Hello, everyone. My name is Bikram Gupta, and I'm the product lead for the container products here at DigitalOcean. We have been working on this product for a while now, for a few months, and we are really excited because it solves a very specific problem. Welcome, and thank you for joining, and we're really looking forward to it.
Awesome. Thanks, Bikram. So, guys, today's topic, we're going to be talking more about Kubernetes Starter Kit for simplifying D2 operations. But before that, before we get started, and this is something that I need because it's like late for me here, the energy level. I and Bikram would love to see more interactions here. Whatever platform you are using for streaming, if you are in the chat, just let us know who are you, where do you live, what brought you to today's talk in general, right? Right now, let me just start. uh, I am right now in Bangalore, India. Bikram.
Yes, I'm based out of California.
Awesome. Okay, so we have Adam from Ghana. Okay, sure thing.
Yeah, we have people trickling in. So,
Yeah, we have Rishikesh, we have Chandan here, we have people from Denmark as well. That's good enough. We have a global presence here. So that's awesome. Okay, let us also know if you're using DigitalOcean Kubernetes or in general Kubernetes, what are you building on it? We would be happy to see that. We have we have Germany, we have Mexico here. It's all those countries. Okay, guys, we also have Phil and Yusuf and Christian from the DigitalOcean team in the chat to answer any of your questions. Although remember that I'm here to help you voice out, so feel free to ask questions, and we will have a dedicated Q&A at the end, so you could have that uh, place for your hard questions for Bikram. So let me know. I'm gonna be your voice out for that. Let me get started on this now. I'm kind of sure that after hearing the topic, you would have a lot of questions in your mind about what's the starter kit, how will it make my life easier, or in general, what's day 2 operations or day 1 operations or day 3 operations. I mean, I'm sure it doesn't exist, but that's the thing. Uh, Here's basically a preview. Bikram, could you just go to the second slide for me?
absolutely. Yeah. And I'm going to go to the full screen mode here so
Yep.
people can see
Awesome. So
clearly.
yeah, here's a preview of what you'll learn. And uh, before going to that, I'll just tell you one thing, right? That we have in this years, right? We have spoken to hundreds of businesses and many developers who use Kubernetes in general to deploy web applications, microservices, CI/CD applications, or anything that is hot, right, in blockchain or in general to learn Kubernetes, right? What we have found out is over the years it has become slightly easier to install Kubernetes with all the managed offerings that's available, like DigitalOcean Kubernetes, or even if you're doing it standalone. However, what happens after you have installed Kubernetes? How do I take care of traffic? How do I take care of backup, logging, security? These were the tasks that were taken care by my operation team. And now I am kind of left out here as a developer or a CTO who thought Kubernetes would make life easier for myself. So this particular problem is something that Bikram is going to cover in the entire presentation, overall talking about the Kubernetes in general, ways to simplify the day-2 operations, the best practices, and then also to showcase a demo which is going to be manual plus the entire automation. That's going to save a lot of time for you. uh, so that's going to be the agenda, Bikram. Yeah, that's going to be the agenda. He's going to be covering the overall Kubernetes there. And frankly speaking, I still remember the first time that I had interacted with Bikram about starter kit, right? Like he frankly wanted to solve this problem. He wanted to make life easier for you as developers and small businesses after you have installed Kubernetes. And over the time when I've interacted with the starter kit in general, I have seen a huge help. So stand back. This is going to be really helpful for you. Bikram, now with all his years of experience, and is going to be covering all the motivation here. We will have the starter kit in general, the overall motivation components, and then a Q&A. Bikram, all to you now.
Absolutely. Thanks, Sachin. And welcome everyone once again. Thank you, and we are glad that you are here. And I can also speak to you from the viewpoint that I am not an expert developer. I'm a product manager and I'm a novice developer, but I play with Kubernetes a lot. There are things that we have learned over time. That is, Kubernetes has become really simple to install. It just takes a few clicks, whether you choose DigitalOcean or you choose any other provider. But the challenge starts after you have installed it. Like, can you think of a time when and the application did not work as expected on Kubernetes? And then what you have to do? The things like you have to look for the logs before 1 week, and then you just didn't find the logs. So there are many times we run into issues in the actual operations that makes it really hard. And it's also the very nature of Kubernetes because it's distributed, because the containers are ephemeral. It's all the more important to have a very solid operation strategy. And that's why we say that. And what we've learned is that the vanilla Kubernetes that you install can be simple, but it's not production ready. When it comes to getting production ready, we like to think of it as in day 1 and day 2. The day 1 is when you create your cluster. When you create your cluster, you have a vanilla Kubernetes cluster. It takes just 5 minutes. And then you still have to do a lot of things to actually deploy the applications in production. You have to take care of logging, monitoring your application and infrastructure. You have to have a good backup strategy. And given that Kubernetes itself is a platform and you are running many applications, you also have to worry about routing traffic to those applications. What we have seen is that it takes weeks or sometimes even months for the newbies to get good at all these skills. It takes time. And on top of that, you have lots of tools because there's a ton of innovation happening. It also doesn't help that those tools are getting updated almost on a monthly or quarterly basis. That's the problem that we want to solve. We want our users to be able to get a production ready cluster in matter of minutes as opposed to investing their time, spending weeks, which basically takes away time from the actual focus, actual business that they have to focus on. Today, we are unveiling a Docs starter kit. And let me be clear that it's not a product. You can think of this as a tutorial. You can think of this as a GitHub repo, as an automation stack. But we are really committed to it in the sense that we have dedicated resources working on it, and we plan to update it over time so that our users can benefit. The goal for the starter kit is not doing anything and everything. The goal is not to integrate all the tools. The goal is very simple. Give a very opinionated tooling and configuration for our users to bootstrap a production-ready cluster. So to start with, we are picking 4 components which we believe are important. The first one is routing traffic to your cluster. Typically, we have ingress, and there are a lot of ingress controllers in the market. For this, we are choosing Ambassador because there are multiple other benefits which I'm going to explain later. The second component is Prometheus, and Prometheus, that entire stack, which is Prometheus, Grafana, and the add-on components to help you get metrics data from your cluster. This is like a no-brainer. Everybody uses it, and this is like proven in the industry. The third piece is how do you get your logs and how do you keep them and visualize them? And for logs, we are using Loki. The last component is for the backup. For those of you who are somewhat new to Kubernetes, you would have noticed that Kubernetes is different from a droplet. In a droplet, your application is isolated. It's contained inside a VM. And it's not that you're updating those applications on a daily or weekly basis. And so the backup can be an important priority, but it can also be done once a day or once a week. But Kubernetes is very dynamic and your containers are changing, your updates are happening frequently, and everything is automated. In that case, when things go wrong, you absolutely want to have a backup strategy. And sometimes, even if your cluster goes down for some reason, you want to have a disaster recovery strategy. And that's why backup should be a baseline component in every cluster. For this, we are using Velero. Now, it doesn't end here. We have identified a few other components around visibility, around security, and around optimization that we eventually plan to add to the list. But it won't be like 100 elements. It'll be anything less than 10 elements that we really believe are crucial to a production grade cluster. In the next 10 minutes or so, I'm going to go over the individual components, and then we'll reserve the bulk of the time for Q&A. This is the block diagram, and I'm hoping that some of you already have access to the GitHub repo because it's public, and we are also sharing that in another screen. While this looks daunting, it's actually simple. Think of one application that you are deploying on Kubernetes. In this case, we are taking 2 applications. One is our echo service, and one is our quote service. We want to expose these services to outside users. And so we are using the ingress, which is Ambassador. And Ambassador itself is exposed as a load balancer service. So when traffic comes in, it comes in through the DigitalOcean load balancer. It hits the ingress. The ingress knows which backend service it should go to. There are other options like Nginx or Istio ingress. And we picked Ambassador because it is built on Envoy. It has a very widely supported community, very active Slack group. It has some large enterprise deployments. And then it works. Like I'm going to show you the examples of the configuration. And it's refreshing to see that with just 1 or 2 commands, you can actually get the entire setup done. The second component is monitoring. Given that your application is running as bunch of pods or bunch of containers, there can be a lot of dependencies. And so it's very important to monitor the metrics, not only from your infrastructure, but from your applications as well. The good news is that it's proven, it's very low overhead. We did not have to invent anything. We took the Prometheus stack, which is well maintained in the community. It's called Cube Prometheus stack. It's a Helm chart. It comes with Prometheus, Grafana, and a few components that you need to be self-sufficient. What we also like most about this is that it has tons of dashboards which are available to you from day one. And those were built by Grafana Labs. Uh, from our analysis, those are something that you need, and you probably won't have to add anything else. So as soon as you install, it's ready for you and it just works with minimal tuning. The third component is logging. Now for logging, there are different options. Like you have Elastic, you have Datadog, you have Splunk, and then Loki came to the scene in 2019, I believe. The way Loki differs from the rest is that number one, it indexes the things that you need. So it uses less amount of space and it is really fast. A log was produced and it's not unusual to see the data in your console in matter of seconds. That's really powerful. The second part is that Loki stores all your logs in the object storage. Now imagine paying for block storage as an example for 10 cents per gigabyte and then paying for object storage at 1 cent per gigabyte. So suddenly you have a massive advantage of cost. Third, the things like the things like log retention. I'm going to show you that even in a default setup, if you didn't do anything, you're generating logs at like 100 kilobyte per second. So you have to tune it obviously and keep the logs that you need. And finally, you need to have some default configuration so that your log doesn't start growing to terabytes. And the good news about this is it can be enforced by configuration. It can be declarative so that you don't have to manually monitor it. So the log retention and log recycling can be automatically done. That's the third component. Now both Prometheus and Loki have the same front end, which is Grafana. The last component we use is Velero. Velero is for backup, and backup is something which I believe that you should not have to touch it unless you have a problem. So your expectation from a backup solution is configure it, check once, make sure that it's working, and then just leave it. Just leave it when you need it in future. It means when your cluster goes down or when an application is not working, then you should be able to quickly go and restore your application or restore your entire cluster. Likewise, if you're migrating from one cloud to another, it's immensely helpful because you're able to take the backup and then restore it in the new cluster. A few words about how or what have we customized and what are we using open source. We are using the upstream Helm chart. We are not touching it. That way we can focus on relying on the community and use a stable Helm chart. Now each Helm chart also has a value file. The value file is the configuration. We customize the value file to make sure that we are using the DigitalOcean block storage and spaces, and we are removing the services that you don't need. You can always customize and add many more things that you need because when you go through the tutorial, you'll see that those options are available to you. You can inspect what you're installing and you can add more or remove things if you don't like. So that's the high level overview. Before going to the next slide, let me just pause here for a moment and see if there are questions. Sachin?
Bikram, we are good. We just had one question from Olivier that if we would touch on GitOps in a bit, but that's the thing we have answered. Olivier, we would touch that. Just wait for the automation demo by Bikram. Uh, you would see more things in action. That's what I'll say.
Yes,
Bikram, we are
yes.
good. Other than that, and definitely after the demo, we'll have a Q&A section.
Okay,
So guys, please post your questions after that.
okay. Okay, so let's keep moving. Uh, I want to I want to address one more thing on why not Nginx and why something else, even though I did answer it clearly. Uh, you should see the actual configuration when I walk you through the demo, and I've done that configuration for Nginx, and you will be able to see the difference. What I found is that Ambassador takes just 1 or 2 steps to give you everything that you need. And so it's just very intuitive and makes it easy for your tasks. And that's why we picked Ambassador. All right, so now for the exciting part, for the demo. Uh, for the demo, there are 2 different parts to it. One part is just walking you through the setup so that you know what you're getting. Excuse me. And the second one is the actual automation. I'd like to cover that in 2 different stages. So let's start with the first one. For the first one, we are going to take a very simple user example, like you can connect with your scenario. Imagine you are hosting two applications on your cluster, and those applications are exposed using HTTPS so that users can access those. And you need some basic things like logs and metrics. And you need things like being able to know the original client IP, because that's when you can do things like analytics and whitelisting and blacklisting and all those things. So that's a very common requirement that we see among our users. And even so-called the curious part is that we also see a lot of issues in that area, like people struggle a lot. So my goal is to show you how simple it can be. And that's the demo that we are going through. So let me just quickly jump to the terminal here. You'll see a little bit of a disruption as I share my screen. Just getting my setup here so we can get started real quick. I'm going to explain what I'm doing, so please bear with me. Okay. Little bit of a hiccup here, guys, because I was connected to the wrong cluster.
No worries, Bikram. Take your time. That happens to all of us all the time with the command prompt.
Okay. Finally, we are here. So first, let's look at what are we looking. I mean, what cluster we have, and then we go through the starter kit one by one. So I'm using some aliases. When you see the output, you'll be able to connect, so I don't have to just speak about the aliases as such. So I have a 2-node cluster here. This is the node 1 and this is the node 2. And as you can see, they are using the instance type, which is 4 CPU, 8 gigabyte AMD nodes. So in total, I have 8 CPU and 16 gigabyte for my cluster. I think it's approximately $96 a month. Just keep that in mind as we go through the starter kit. 8 CPU and 16 gigabyte total. Now let's see what have I installed to the starter kit. Uh, if you look at the starter kit, you'll notice that here we have given the instructions for how to install individual components. We are using a very standard practice, so you don't have to you won't get confused. Helm for everything, and we use upstream Helm, and then we customize the value and keep the values in our GitHub repo, so you know that you are using something that's tested. So we are using purely open source tooling and just customizing it. So let's see in my cluster what has been installed. I'm going to type the command, list my Helm charts which are installed. So as you can see, I have my Ambassador, Prometheus, Loki, and Valero. I have 4 components which are installed, which is straightforward. And those are the components of my starter kit. So this is a cluster that has the starter kit installed. Now let's go back to our objective. Our objective is to expose 2 applications that are running in our cluster to outside. And so let's start with the applications first. So I have a backend namespace. In that I have 2 applications running, and both applications are exposed as services. And as you know, the cluster IP is internal to the cluster, so it really is not exposed to outside. Now our goal is to use Ambassador to expose it to outside. Let's look at the Ambassador installation first. So I'm going to look at the installation first. And as you can see, the services in the Ambassador namespace have a service called Ambassador, which is load balancer service, and that has an IP address of 143.138. So this is the external IP, which is the IP address of the DigitalOcean load balancer. And when a traffic comes to that load balancer, that traffic gets forwarded to Ambassador. And at this time, I have 2 replicas. You can think of this as proxy, envoy proxy. I have 2 replicas of Ambassador proxy which are running on my cluster. So the installation looks good. Now let's see how we can expose our services to outside the cluster. This is the crux of the configuration. So I'm going to show you the configurations needed for that. I want you to look at the echo element. We'll just stick to that for a moment so it's easy for you to understand. I want to expose my echo service in the cluster as a host name, which is echo.simplex-hosting.xyz. And so for that, I have created a host resource in Ambassador. Now, it's a host, like virtual host in Nginx, but I still have not created the mapping that's going to map this host to a backend service. So let's do that. Look at this line. What this is saying is that when it's a mapping, when traffic comes to this host on this prefix, then send it to the echo service in the backend. It's that simple. You want 100 mappings, you create 100 mapping resources. You want a different prefix, change the prefix. You want a gRPC API or REST API endpoint, this becomes a REST API endpoint. So there's a rich configuration that you can support as part of the mapping. It's very, very flexible. And that's why it's both a ingress as well as an API gateway. So we started by creating a host for our individual application. Then we created mapping for a simple prefix. Now let's try if it works. So let me do that. Curl. I'm just going to take this as is. And obviously I want the output, so let's see that. So what happens here? The first thing that happened was it says that it's redirected. It's basically redirecting to HTTPS. I want you to look at that. It's redirecting a simple HTTP to HTTPS. And then this is the response from my echo application. So it is TLS, number one. It's doing a redirection, number two. And third, look at this XFF. This is IP address. What's this IP address? So I'm going to look at my IP address of my laptop. This is the original IP address of my laptop. So basically, Ambassador also enabled the actual client IP address for the end applications. That's a lot. And what we did, we just did two configurations, host and mapping. And that's powerful. That's really simple. For those of you who have gone through the configurations, you may remember doing cert manager and bunch of other things, lots of configuration. So it's worthwhile now. Let's look at what's inside that host and mapping. So going back to the same thing here, I'm going to do host. So this is the host that we configured for Ambassador. For this, look at the lines here. The first one is my host name. It's a straightforward thing. The second one is if you see a HTTP request, redirect it to HTTPS. The third one is use TLS and use this secret, use this cert. Now, how do you get this cert? And we are telling Ambassador to use Acme protocol to get it from a certificate provider. In this case, we use the default one, which is Let's Encrypt, but you can use your own certificate provider. So that's all that we did. We get the host name, we enabled the redirection policy, and we used Acme protocol. And we did not have to do anything else. I'll show you the actual YAML file so you can connect to it. So this was the YAML file. You can just take it, customize it to your need, and you get a TLS enabled application. Now let's look at the mapping. Mapping is extremely simple. All we are saying is for this host, if you find this prefix, send it to this service. Let me do a smart thing here. Instead of this, let me use the quote service. So I'm trying to see if I can basically use the quote service to access this prefix. So you can have 10 different applications, but in the mapping resource, you can explicitly state what prefix or what API endpoint belongs to which host. That's again quite elegant. We'll get to the questions in a moment, and I'm sure that we have Phil and a few other folks, Sachin and Christian, who will be responding to your questions in the chat. So we sent a few curl requests. We looked at the configuration. What I did not show you is what's the magic behind the actual client IP address. And that's the third configuration. So there is a modules configuration file. And in that, we are simply using this. We are saying enable the proxy protocol. That's it. For this to happen, we also have to enable the proxy protocol on the DigitalOcean load balancer. And for that, I think many of you know already. I'm going to show you that anyway. In the annotation, we are using proxy protocol to be true. That's all we need to do so that proxy protocol is enabled on the DO load balancer. So this is amazing. I mean, we just did host mapping and enable the proxy protocol globally, and we are getting everything that we need. And you can do it for as many applications that you want. Now that we are sending some traffic and we have an application running in production and we are scaling, obviously we would be interested to see, the metrics, the logs that are there for the user traffic, because that's like a baseline requirement. So now let's switch to the Grafana and see that. I'm going to do a very small thing here, basically run a quick load test on one of the services just so that we can have some good dashboards. And here I'm using WRK, which is a load testing tool, sending it for 1 hour and using 5 connections. I'll just start it. So now it's sending a few connections to one of the services. And here I'll go back and do some more curls. So basically I have some failed requests and I have some requests that went through fine. Now it's time to head over to Grafana. So this is the Grafana dashboard, which was installed as part of Prometheus Helm chart. And first thing I want you to notice is there are lots of dashboards which are already available to you. And I'm going to show you those a little bit later. But let's start with Ambassador dashboard. Going to change it to last 5 minutes just so that we can get the latest data and look at the API. So as you can see, in the last 5 minutes, we started the load testing, and suddenly you see that our redirection is starting to increase. Our response is starting to increase, that is 2xx, right? And because the load testing is sending bunch of tools, bunch of connections, you're starting to see the response here. Likewise, the same API responses, right? This is the downstream connection that it has established and how many active connections are there. And because the Grafana dashboard is just a mirror of the Prometheus, there are tons of metrics that Ambassador is exposing. And eventually we'll customize it by working with the Ambassador folks, but you have full control on what you can customize. So this is about the metrics. Let's get to the logs now. The logs are on the Grafana console as well, and we are going to the Explore tab here, and we are going to select Loki for visualizing the logs. And I'm going to look at the log browser, it's quite intuitive. Look at the namespace. I'm going to select ambassador and just show logs. And again, let's give here last 15 minutes. So we are keeping our query limited. So now you can see that logs are coming at a regular rate. Now there are lots of these logs which are being generated. If you look at these logs, I think it should be obvious to you that it is being generated by the load tester. See, it's trying to get to the quote and get the quote value from the quote domain. And there are a few small things like you can see that it's indexing all the metadata. It's indexing all the metadata, so you can easily access for any pod, any label, for any duration. You can really do a fast search. It's not indexing the actual headers. For that, it's using the regular expression search. And I'll show you an example in a moment. The other thing I want you to note here is that let's say when you are troubleshooting as a developer and you have all these logs coming, and for some logs, if you are interested to know the context, you should be able to see the context for the logs by hovering your mouse. Right now, I don't see it here. It's quite intuitive. There is a context button here that you should be able to see that so-called time machine. What happened before this log and after this log? That's called context. Now let's try to find out the logs that we sent through our explicit curl request. So there are a lot of different regular expressions, and you can see by looking at help. I'm not going to go through that now, but we know what we are looking for. So I'm going to look for a pattern which is echo dot simplyhosting.com.xyz. So I'm going to find this info, run query, and as you can see, echo simply hosting XYZ. I was trying to get the echo path. That all went through fine. But I was also trying to look for a echo path in quote.simplyhosting. Let's try to find that. Go quote dot star. And then I'm going to look for echo.simplyhosting xy quote, and I'm looking for echo path. Very standard Unix regular expression. So as you can see here, I was trying to get the quote simply hosting. I was trying to get the echo path and that failed. If you remember, it returned nothing, right? And see, this shows the context of before and after what happened. And if you recall, I was trying to try different type of curl requests, right? So this is extremely helpful for you as a developer because it meets the use cases of retaining your logs, searching your logs, and then automatically recycling your logs so it's hands-free. You don't have to like have another engineer trying to manually recycling the logs. So that's about Loki. Just to recap, we started with 2 applications in our cluster. We exposed it using TLS. We tried different type of requests, and we looked at the metrics and we looked at the logs for all those requests. One last piece before we complete the demo here. I want you to look at the cluster resources. One obvious question is, I've got this 8 CPU and 16 gigabyte of RAM, and how much resource am I consuming? And you can see that I'm consuming well below 1 CPU. Excuse me. Well below 1 CPU, even when my cluster is under load. And this is not only, this is Cube system is using the bulk of that. Some are used by backend service, as you can see. Some are used by Ambassador, and lot is used by Monitor. Yeah, this is Ambassador. So because we are loading Ambassador, you see the CPU usage increased. This is one part. I want you to see the networking part as well so that you know what you're getting. So at a very crude level, you can say that Cube system, there is a lot of traffic going on, but the good thing is in Cube system, the traffic remains inside the cluster. But you can also see that when I started loading the system, there is a lot of traffic from the monitoring, both in and out. So while the interesting part is while the backend service is only 18K, Ambassador is only 18K, the monitoring is almost 10x. And I don't think it's any different from your experience for log handling. Logs can go crazily expensive. And so in future, we are going to make sure that we tune it down to capture the logs that you need by default. And then we aggressively tune it down to 7-day retention so that even if you leave it hands-free, your costs are still in pennies and it doesn't create a stress on you. But something for you to know, and hopefully you can appreciate how the logs can go really expensive very quickly if you're not controlling the cost. With that, I'm done with the first part of the demo. And before getting to the next slides, I want to pause here and see if there are questions that we need to address. Sachin?
Awesome. That was great, Bikram. We do have some questions here, Bikram, like on the cert manager page with the TLS when you had done the demo. Oliver wanted to know, like, will the certificate automatically renew after 90 days?
Yes, because it's using Acme protocol,
Hmm?
which is very well supported by all service providers. It'll automatically renew. It is hands-free.
Okay, got it. And how it looks like with the wildcards, like the subdomains that you had mentioned in the ambassador, that wasn't the question.
Yeah, that's a good question. I know for a fact that it works. You
Hmm.
can get it. Let's take that as an action item and I don't know the answer right now.
Yep.
We'll also try to include that in the tutorials so that people know.
Hmm.
I'm pretty sure it's a use case for many people.
Yep, that's good. And then we had one more question around ambassador that right now the free plan has like 5 requests per second as a limit, right?
It is not. It's not. It's actually 5 requests for limit for some of the paid features. Let's say that
Yeah.
you are exposing your services and then you want users to authenticate, users, meaning end users, using OAuth, single sign-on using Google or Facebook. That's like a lot of work. And imagine that if you could simplify that using mapping resource. So that 5 requests per second is when you are exposing the API and you want the API authentication using a third party like Auth0, and you want to do single sign-on. So for some of the complex enterprise feature, that limit applies. For anything that we are showing here in the tutorial, the limit does not apply.
Okay. Awesome. Thanks a lot, guys, for all your questions. Please keep the questions coming in. We would actually take that live here. Um, Bikram, before you go to the automation part, I was a bit curious on that part. I mean, all the things that you covered, like ambassador and all the things with the dashboard, uh, how much resources like should we allocate there, right? You kind of
Yeah,
mentioned they take less than 1 GB, right? I mean, for all that it is less than 1 GB. I mean, uh,
yeah. And
that's what I
and we
wanted to
want to be
understand.
transparent to our users. This is something
Hmm.
even I'm very curious. I want you to note when the cluster starter kit was installed, the CPU was consistently below zero point 0.5.
Hmm.
As soon as we started loading with the user connection, the CPU usage increased. But look at the usage monitoring. And we know the problem because Loki is generating lots of logs for each and everything. And so it's taking that many resource. And still it's remaining below one, the CPU. Memory, it is staying consistent at less than 2 GB. And remember that includes cube system as well. So when I said 1 GB, we just combined. If you combine all the memory uses from all the starter kit components, you see that stays around between 1 to 2 GB when the system is starting to get loaded. I don't have any magic wand to say how much it's going to consume. You have to figure it out. But I can tell you that in default installation, it's less than 1 GB. And obviously, if you have applications which are getting overloaded and it may consume more, but our assessment is that it's nothing in comparison. Like we had 8 CPU and 16 GB of RAM. Cube system is already taking a good chunk. And if you just add one CPU and 1 GB or 2 GB for starter kit, you still have a lot remaining for your applications.
Yep, that makes sense. I mean, thanks a lot for that explanation, Bikram. This overall thing, what you have showed, I mean, I I have been a bit curious on that, and I have questions, but I would let you demo the
Yeah,
automation part first. Uh, we could actually run through it because that's going to be super important.
yeah, yeah. So now coming to the demo. The demo is, while it looks a little bit again complicated, it's actually simple. We have taken very standard cloud native tooling. And if any of you are not familiar with what GitOps is, I highly recommend. I mean, when I started using it as a novice user like a year back, I'm hooked to it. And for the simple reason that Kubernetes is declarative and cloud is declarative for that matter. And it means ideally you want to keep your configuration in a Git repo, and you should not have to worry about how that configuration goes to your cluster. Let a GitOps tool like Argo and Flux take care of that for you. It has multiple advantages. Even if the configuration changes in the cluster, the GitOps tool will address the drift. That's huge. Like you can always be confident that your cluster is in sync with the source of truth. Next, if you have multiple people working on the cluster configuration, they just send pull request to your GitHub repo. They need not have access to the cluster. Very secure. Third, when you have 10 clusters that you want to create, but you have one configuration in the Git repo, guess what? It takes minutes. You don't have to do any manual work. You don't have to change anything in your Terraform. It's quite elegant. So, so we decided to pick Terraform for creating the cluster, and we decided to pick Flux for doing the GitOps or for automating the installation of the starter kit components. We also had a few objectives. We didn't want to force everything on our users. We wanted our users to pick what they want. If you want just Ambassador, go for it. If you want just Valero, go for it, by all means. And we also wanted our users to customize and not take our Helm values for granted. Let's say that you know that you are creating a 50 node cluster. And so you know for a fact that you need 5 replicas for Ambassador. Then you should not have to worry. You should just be able to customize what you install while still depending on our values file. So you have the flexibility to pick what components you want and how you customize. That's a pretty big deal. With that in mind, it's actually simple. Using Terraform, you fire up a cluster, and then you have a Git repo that must be private. Let me emphasize it. Your manifests are containing your secrets. They are staying in GitHub, and it must be private. You cannot afford to make it public, and there is no reason for you to. So your Terraform bootstraps the cluster, it has a Flux installed. The Flux is connected to the Git repo, which is a private Git repo. And now all you need to do is commit the manifests for your individual components, like Ambassador and Prometheus, and Flux will take care of it. You want to change something, you want to delete a component, just remove it from the Git repo and Flux will take care of it. You should not have to do any kubectl after that. So let's see that in action. I'm going to do a quick time check here. Sachin, how much time we have? Like, do we have like another 10 minutes?
We have 4 minutes, Bikram.
Okay, let me rush through it real quick. Uh, on the upgrade part, again, it's very simple. We are going to maintain the starter kit version, which is aligned with the docs version. So when you are upgrading from 1.21 to 1.22, all you need to do is to point your starter kit resources to 1.22. I'll just show you in 2 or 3 minutes, and then maybe we can stay for another few minutes, record it, so even if people drop off, they can listen to the recording later. How does this sound?
We can, Bikram. I mean, we can go over a
Okay,
bit just to show the automation part. That's going to be super important.
okay. So now I'm going to switch to another cluster, which has this is my automation cluster. And remember, I told you about the GitOps tool. So let's see whether that's installed. So I have my Flux system, which is installed. That's my GitOps tool. Now, how do I know which Git repository is connected to? So it has this has a Git repository, this one. This is the Git repository, which is the source of truth for my Flux repo, this one. So I'm going to go to this Git repo. This is my Git repo. So now let's see what Flux has installed so far. This is the system data for Flux. It won't change. It'll be installed by Flux. We don't have to mess around with it. And these are the Helm. This is the Helm chart that Flux has installed for me. For every component, you are going to install two resources. The first one is the repository. Here I'm telling Flux that use the Helm repository from the ambassador. So remember, I told you that we are using the Helm chart from upstream. We are not messing around with that. Only thing we'll do is for every docs release, we'll test and we'll pick a stable Helm chart. So you don't have to spend that time. So we are picking it from the upstream. So this is very intuitive, very simple. Let's look at the second manifest. So we are telling Flux to use a Helm release from this Helm chart. See, we already saw that Helm chart before. And we are telling that for the Helm chart, use this version. I told you that we are going to use a version. Ideally, you want to trust us and not customize it, but you can very much do so. It's in your control, as you can see. And then this is the value file for the Helm chart. This is the value file which we are recommending. Now, if you want replica count 2, go ahead and do it. Replica count 3, go ahead and do it. By the way, by default, we are using replica count 3, not replica count 2, not 1. I just did it to show the working of GitOps. So that's why you see here 1. So let me make sure that's the source of truth. So you see there is just one replica running. Now I'm going to do one small thing, which is oh no, it's installed in the Flux system. So now I have one replica here. Let's say I want to change it to 2 replicas. So I'll go to the Git repo, which is as you can see, this is my Git repo. And I'm going to change this file to change it to 2 replicas. And now I'm going to just commit it. And then I'm going to push it. So now it's gone to my GitHub, and let's verify that. I have 2 replicas. Now, Flux is supposed to sync every 5 minutes. You can do every 1 day because why create unnecessary load? So I'm going to ask Flux to reconcile by force. So I want you to make a note of this Git BB8C, and let's see what happens here. See? Okay. Want to make sure I look at the right one. BB8C. See this one? So Flux has picked up the latest thing that we committed. Now let's see if that's going in action. Flux get Helm release. Succeeded. I have 2 replicas. So all I did was change the replica count to 2, pushed it to Git repo, and it worked. I'll show you one last example in 1 minute, and then we go back to Q&A. So going to the automation part here, and we are going to install a Prometheus from scratch, so you know how simple it is. The first is let's create a Prometheus release file, or the Helm repository file, which is already done. So we don't spend time on that. Git start us. I already have it. Let me just show you. So it's already there. We are saying that source it, update every 10 minutes from the upstream. The second is create a release chart, and we already have it. So I'm going to just show you here. Helm release, and this is the value file. And you see the Grafana password and a few things. So now you can automatically notice that you cannot afford to put this in the public Git repo. Your value file will have credentials. Your Git repo must be private. There is no reason for that to be public. And we have also put that in the notes. In the next week or so, we are going to take care of that by using sealed secrets. But then you must not use your Git repo as public. And so now I'm just going to install it. Let's see what happens. I'm going to add, commit, and push. So pushed it. Let me make sure it shows up here. It's ready. It's showing up here. I'm just going to do a reconcile so we don't have to wait. It picked up the latest one, and I'm going to just go to a get Helm release. See, it'll take a while, but then my Prometheus will be installed. So this should answer the question of you are in control of what components you install, and you are in control of how you customize. My only ask, and we have explicitly made it clear, that be careful of what you commit to Git and make sure that your Git repo is private. With this, I'm going to go back here. I know we are running out of time. We talked about upgrade, and let's summarize. So we covered a lot of ground, and hopefully you guys found it helpful. If you're new, spend some time. It'll take a weekend or so, get a hang of the tools, do the manual steps, and then you will be ready to create your own cluster in a repeatable manner, once in about minutes. And then we are going to update it time to time, add more components. We'll also be active in Kubernetes Slack channel for DigitalOcean. You can also file issues in the GitHub, so feel free to reach out to us if you have questions. And if you have PRs, by all means, submit those. With this, I'm done with my part. Let's address the questions if there are.
Awesome.
Sachin?
We do have it, Bikram, and we are good with time. We could actually take additional 5 minutes, guys. That's the thing. We could just have the Q&A here immediately. We have already covered the summary. We could just wait for you a bit to answer those questions. Bikram, Oliver wanted to know, like, can Flux differentiate between branches or label for environments like staging and production as well?
It does, and there is a set of guidelines on how you can have a single source of truth for manifests and
Mhm.
then customize those and deploy those into your staging and production cluster. There is a document by Flux that we can share, and there is a GitHub repo that I have and we have in our container blueprints as well that we can share with you. In fact,
Sure.
that's the thing that I demonstrated some time back. So we'll just share the link here later.
Sure thing, Bikram. And
Yeah. And we'll take that as an action
okay,
item, put that in tutorial as well, because I think that's a very common use case.
got it, got it. You should have the link now, guys. Bikram, why did we choose Loki in
Yeah.
comparison to the well-known standard Elasticsearch?
Yeah. So Loki came to the scene in 2019, written in a very cloud native way. The thing with Elastic, and I have used Elastic, is that there's a lot of management overhead, and I don't think our users are ready to do that. In Elastic, it's a lot of work when you are adding a node, when you are doing maintenance, when you run out of storage, and when your scale grows, because Elastic is indexing everything, it's really you need a lot more resources. So Loki was a no-brainer, keeping the use cases of our users in mind. Our developers need hands-free logging. They need to retain the logs for, let's say, 15 days or for a month and automatically recycle those. They need to be able to quickly search the logs based on different metadata and see the time machine, which is the context. And preferably, they use the same console, which is Grafana. And Loki is extremely fast and very cost effective. These are the reasons why we picked Loki, keeping the use cases for our developers in mind.
Got it. And what about the data durability or the persistence here? Since in the logging, you had mentioned about the DO block storage overall, right? Like, are there any plans for failover?
Yeah, so DO block storage and DO spaces are redundant by default. We have the required, we do all that thing in the backend, so our users don't have to. Our users can be assured that the data is safe. And that takes away the pain of users having to manage HA for their data. And Loki uses the spaces, so that's cheap. Like your block storage is 10 cents per gigabyte. Your spaces, uh, don't quote me if I'm wrong, is I think 1 cent per gigabyte. So it's dead cheap.
Yep.
So
Yep.
all that you need to do is put the retention policy for Loki to recycle every 15 days, and don't worry. Only additional thing we'll do, guys, is we are going to change the configuration for Loki so that you customize what logs you want to capture. Because just now I showed to you that when we had a load of 10 kilobyte per second on ingress, Loki was like running at 100 kilobyte per second. And so we're going to tune bunch of things to make sure that your log volume is not too high. By the way, that's true for Elastic as well. I've seen it in my prior
Yep.
life. And so I explicitly disable the logging for Cube system unless customers need it.
Exactly. That's the thing. I just had one last question here, Bikram, for you. Like, since you just mentioned about HA, right? Highly available clusters, since that is a feature for Kubernetes in general, um, why should I go with backup? Like, in general, my clusters are highly available, right? So,
Yeah,
can you speak about that difference? Kubernetes
yeah,
feature is highly available. Why should I back up my cluster?
yeah. So Kubernetes, when we talk about high availability, it's for the control plane. So we are guaranteeing that the API is always accessible. But when it comes to application high availability, what we end up doing is run different replicas and make sure that even if a container goes down or even if a worker node goes down, the application is still up. But what happens if your entire cluster is down because that region is down? In that case, if you have the backup, then you can actually restore and start a cluster in another location. But I think a bigger reason for backup is how you update your applications. Let's say that you are updating every day, and tomorrow you realize that there was a major problem with your application, and you really could not roll back. You really could not roll back, and even if you roll back, the data was corrupt. In that case, you are going to need backup so that you can go to yesterday's backup and just restore it. So that's the scenario, that's the use case that we see in most of the places. When the application gets corrupt and you really cannot go back to a previous known good state, that's when you're going to need the backup. The other use case is when you are migrating from one cloud to another or when you are migrating to another region. The third use case is when you are upgrading. Let's say you're upgrading from 1.14 to 1.21. Do you do that like 1.14 to 15 to 16? It's a lot of work. Sometimes you may just like to just upgrade easily. And that's when in one step, and that's when backup comes into the picture. So hopefully uh, it clarifies the HA for Kubernetes versus the HA and failure scenarios for your applications.
Yes, absolutely, Bikram. I mean, the control plane part was like super clear there. So, thanks a lot for explaining that patiently. And thanks a lot, guys, for giving us extra time there. We internally are quite bullish about the starter kit in general. We will be posting the upgrades there. um, it is completely open source there, so please do submit the PRs. Please do have the questions coming in as well there. And thanks a lot for listening to us overall. Bikram, do you have anything for the audience?
Oh, well, I mean, we are really passionate about it. We have spent time trying to make your life simple. We really hope that you enjoy this, you start using it, and we are going to keep iterating on it. Thank you, everyone, once again.
Awesome. Thanks a lot, everyone. Bye.